Hello everyone! In this video I will show you a nice way I discovered on how to use sprite sheets inside of Blender's shader editor. Sprite sheets, also known as texture atlases or flipbooks, refer to multiple images packed into one large image in order to save memory and performance. We'll make this applicable inside our materials with a bit of vector math. If you want to download my full assets directly, I've linked my Gumroad page in the description where you can find a set of 3 node groups. The first one is just to make sprite sheets usable in general, while the other ones add animation. The interpolated sprite sheet function allows for blending the different tiles as well as advanced time control during pauses or to ease the animation. This tutorial will cover the bare bones on how to set up a sprite sheet, how to animate it, and finally how to achieve a smooth transition between the images. It's recommended that you have a basic understanding of Blender and the shader editor, as well as general math functions. Okay, let's create a regular sprite sheet in order to use multiple images packed into one. What I have here right now is a Minecraft seagrass texture, which uses 18 images vertically, so it's squished down. The reason for that is, if you take a look at our UV map, this has a range of 0 to 1 for the X and Y direction. So if we have to squish down our image on the Y, it will be mapped incorrectly, of course. So what we need to do to our vector in order to transform it properly, we will scale and then shift by a certain tile amount. To demonstrate, I will add a different image. This is going to be an 8x8 tile grid, and this is going to be mapped correctly because it's a square like a plane. But what we're going to do here now is take a combine XYZ, group that up, delete the Z, and of course we're going to need an input vector, which will be put in between here. And we'll just run the input to the output in order to get our image back. And in order to only have one tile visible at a time, we will scale the whole vector down, or a whole UV map. So we need 2 variables. One is going to be count X and one is going to be count Y. So those are going to be integers, of course. And those are going to decide how many tiles we have in our grid. In this case we have 8x8, and I'm going to duplicate this in order to have a tile variable, and this is going to decide which one we want to view. So in order to first scale everything down, we're going to use a divide node, and we're going to divide by the count X and the count Y as one vector, and this is going to divide up our UV map into 8th. So it only displays one part of our image, of our image. So now we have the correct scale, and we're going to shift it now with a vector math add to shift it in the X direction horizontally and vertically. We can do that by taking a tile and a modulo function and use the count X for it. This will allow us to let tile count up as it progresses, and then as soon as it reaches our maximum of X, it's going to jump back down to 0. That's what we need in order to have it go to the right and then jump back down. We'll use another combine, plug this into here, and now if we use our tile, it's going to go to the right and jump back down to A1, but we want, of course, to have this jump up one row as soon as it finishes cycling one line. So we'll do that by taking the tile again, dividing it by the count X, and what we're getting now is a fractional value starting at 0 if we're in the bottom row. So if tile is anything below 8, let's say 4, our value will be 0.5. So we divide 4 by 8, it's going to be 0.5. For 6 it's going to be 0.75, I think. And so we always have 0 point something. We can make use of that by taking a floor function. This will round all values down to the nearest integer. So if we got fractional values here starting at 0, they will all be interpreted as 0. So we don't have a line shift while we're still going to the right. But as soon as our tile reaches 8, it will divide and we will get 1 as a result, and this is going to be rounded down to 1. And we just use it as a Y. So now it will wait until one row is finished, and then increment by 1 and shift it vertically. So now it works already, and as soon as we reach A8, it will jump back up 1 row, and keep going. And even if we go beyond our maximum, we're gonna jump back down to A1. In some cases you may actually have a sprite sheet which is supposed to go top to bottom. For that we can make a little adjustment. We just need to adjust the y-axis, and we're going to use a mix in order to determine if we want to go top to bottom or not. We'll introduce a new variable, which is going to be a boolean. Let's call this top down, and we'll just plug it where the floor went. And right now it's not going to affect anything because it's disabled. When it's set to 0, it's going to give us our A input, and if it's set to 1, we will get our B input. This is true and false respectively. And now we can take our count y, subtract 1, and take another subtraction and subtract our floor by it. But this just tells it to start tile 0 right up here, and then just subtract our shift, so we get down instead. We need to subtract 1 here in order to start at tile 0, otherwise we would start at tile 1, but we want to start at 0, like bottom to top. And now we need to plug it into B, floor goes onto A, and if we now set this to 0, it's going to be A1, but if we now enable the checkbox, it will start at H1, and because we didn't change anything about the x-axis, it will continue to the right, but then jump down, and even if we continue down, after A8, it will jump back up. In some cases you may actually have an image which doesn't use all of the tiles in our sheet, so even though we got an 8x8 grid, we're not using all tiles. Those 4 are transparent. But because the sheet doesn't know that, it will continue, and as soon as we reach 60, because those are 60 tiles, it should wrap back down to 0, but it will continue for the empty tiles. And this might be not what you want, because it doesn't loop properly now. It will go through all of these and then go back down. So we can fix that by adjusting our tile. So we introduce a new variable, which is going to be called sheet length. And if we now take our tile and add another modulo function, we will limit our tile to our length. So this will stop counting and jumping down to 0 as soon as it reaches the sheet length. However, we might not want to set this every time to know how many tiles we have. We can just take a greater than and check if it's greater than 0, and then use a mix to decide if we actually want to use that function. So we'll plug it up like this, and now only if our sheet length is greater than 0, it will snap our tile back to 0. But if it's 0, it will just ignore it and the tile will continue normally. So now at 61 we have a transparent tile, but if we now set our sheet length to be 60, as you can see it switched the image because it knows when to stop going through the sprite sheet and will jump back down. And now we have proper tiles, so 60 is going to be the same as 0, and we can just cycle through it into the loop just like we want to. Alright, let's talk about blending different tiles. What you might encounter is a texture that's supposed to have a smooth transition between each separate image. In this case it's a Minecraft Sculk texture with 4 tiles, and if we switch the tile now, it's just going to cycle through the images. But to showcase that, let's use a tile grid, and it will just snap to each image. Works like before. What we need to do instead is we want to have a smooth blend to the next frame. This is not possible by using the vector only, because the vector can only decide where on a current image we want to be, but our image doesn't have the blend frames we may need, so we need to duplicate that. I'll use the same UV and skip 1 tile ahead. Take a mix between those two, and now we can blend. So we always need a mix after the fact in order to blend them. So what we're trying to generate now is one vector, another vector, and a factor to blend those. The behavior we want is to have this be one step ahead, blend over, this to switch 2 steps ahead, so this is at 1, this is at 2, and then it can go back, and we go forth, and this is going to continue cycling through our image with perfect blending, only using 2 images. What you may have seen before is people taking individual images, not on a sprite sheet, and just mix these together like this. So they just have a lot of mixed nodes, which they output here, and they use factors to control when the second image is shown, when the third is shown, and so on. But this is very taxing on performance, so instead we're only going to use 2 images here. This is going to be always 2, no matter how many tiles we actually have. We could have thousands, whatever. It will always have 2 tiles, 2 textures, in order to just get the switch, but we can always switch back and forth in order to interpolate properly. Let's create a time function first in order to have an automatic animation. We'll take an attribute node and view layer mode and type frame_current, as well as render.fps. If we now divide our current frame by our FPS, we will get seconds. So the seconds will be completely independent of our frame rate, so we can select any frame rate and it will have the same time. If we now use this as a tile input, and look at this, it's going to switch between those. Of course, this is going to be a fractional value now, so it's going to smoothly switch the tile. There's a little issue with the tile. Even though it's an integer input, it will be interpreted as a float if we have a float in here. So we can circumvent that by just either taking a floor function here or just take a floor function out of here. And this is going to just keep setting up. I will actually put it inside for now. After here. Or actually maybe before that. Yeah, let's take a floor function here. And plug it in there. And now it will make sure this integer is actually always interpreted as an integer, not as a float. And we'll keep counting up and cycle back down. Let's now make sure we adjust our time function in order to allow for a smooth blend when controlling the factor. If we say this is our timeline, and we have our image A and our image B, we will start off at tile 1 here, or the first tile basically, and we're going to blend to the other image, because we can't blend in the same image, to tile 2, and then blend back to tile 3. Let's go ahead to tile 4, 5, 6, and so on. And what we need to make sure here is that it needs to stay at 1 as long as it interpolates, and then switches to 3 in order to be able to blend back. So as soon as it reaches 2 here, we will switch to 3, and we will keep the 2 while it interpolates, and then switch back to 4. And goes to 4, switches to 5, goes to 5, switches to 6 here. So you may notice a pattern right here. We always have pairs of 2 values, which stay there for exactly 2 time units. And to recreate this behavior, we're going to take our time. Let's do it like this. And we're going to need an add node and a snap function. What snap does is it rounds down to the nearest integer multiple of the bottom value. So if we count arbitrarily 1, 2, 3, 4, 5, whatever, this will make sure we only count 0, 2, 4, 6, and so on. So it will round down if the value would be 1, for example. So 1 is not accepted, it will round back down to 0. As soon as it reaches 2, it's going to snap to 2, and then keep it at 2 as long as it didn't reach 4 yet. The reason we need to shift it by 1 before, so we're basically just shifting the time, is because we need to create an offset for when it keeps the value. Because if we had the boxes above each other, the cut would be visible. They need to snap always when the second image is shown, so it needs to be offset. This is going to be the input for our first sprite sheet. And in order to create the second behavior, we can just switch those around. Exact same values, snap to 2, add 1. And what this does is it takes the regular time, doesn't shift it, but what it does is shift the tile that is viewed. So let's say this is our A in this case, this would be our A. This is not shifted in time, this is shifted in time, but here we are shifting the value, so it's odd increments. It will increment between 1, 3, 5 and so on. So this is already everything we need for the tile input. And now if you view one texture, it's going to cycle through these. Always going to be 1, 3, 1, 3. Let's speed this up a bit. And this is going to cycle with even increments. So now the only thing that's left is controlling this factor. And we actually have a function which does this zigzag behavior, which is going to be the ping-pong. Ping-pong is actually just a different kind of modular function. I'll show this real quick. So while if you view our modulo, it's going to let the value rise until the maximum, then jump back down, rise again, jump back down. But a ping-pong does the same thing, but it inverts the second phase, so it has a linear gradient downwards. So instead of snapping down, it will invert and go down, go up, go down, go up. So it's basically just like a sine wave, but triangular. This is exactly what we need. We need to have a maximum value of 1 because we're using a factor from 0 to 1. So it will be scaled to 1. And now if we plug this into here and view this, we already have the blend. And this works for any amount of tiles. There's already a functional blending of the sprite sheets. But what we can do, of course, is, for example, take a float curve and edit our graph, so that instead of a linear function, which is this, we can have a easing one. It will take longer to start, speed up, and then slow down again. But now we might want to randomize which tile is currently shown. So if we have multiple objects, it's all going to look the same. So if you have anything that's supposed to be random, that's not good. What we're going to do instead is add to our time, because the time just controls the current tile, as you can see. And we're going to take a object info random. We need to multiply the random by a high value, because random is just going to give us a value between 0 and 1, and we want to have a random integer per object. So let's take 100, and we will floor that as well, in order to have integers. And this will now randomize it. Of course, randomization will look a bit more effective if we have a lot more tiles, but it's just to prove the concept. Right now, those show different tiles, or at least they randomize the tile, but what we can also do is shift when they interpolate. So we need a fractional value for that. We can just add one into here, and we'll take another random. It's going to actually put out output the same value. So we can take a white noise texture. White noise just gives a different random value depending on the W seed input. So this is just going to change the seed of our randomness basically and differentiate it from this random. And we can just plug that into here. And we will have a time offset to determine when it interpolates. If we take a look at our sculk texture again, this looks just like in-game, with randomness and smooth blending, and it will be random per object. If you enjoyed this video and want to support me, please leave a like and subscribe to my channel in order to not miss out on any new tutorials. Also check out my Gumroad page to get access to high quality assets. Let me know what you think in the comments, and thanks everyone for watching.